Hello, everyone. It is indeed a pleasure to welcome you to In Conversation with Stratview. Dear viewers, when printing as a technology was introduced around 1440, no one could ever have imagined that one day we would be seeing printed orthopedic implants, complex industrial tools, and even printed fuel nozzles for giant jet engines. Yet, that is precisely the reality we live in today. Today, we are talking about the technology that has made all of this possible: additive manufacturing. Dear viewers, this is me, Vyapak Tiwari, your host for the day, and joining us for the conversation are two very distinguished individuals, Mr. Rajiv Bajaj and Mr. Deepak Agrawal. Let me begin by introducing our first guest, Mr. Rajiv Bajaj. Mr. Bajaj is the managing director of Stratasys India, with over 20 years of experience in the technology industry. Mr. Bajaj leads Stratasys India and Southeast Asia team to drive sustainable growth of the 3D printing business in the region. Prior to this, Mr. Bajaj was the country manager at Autodesk India and SARC, heading the manufacturing solutions business unit and managing the growth strategy across different industry segments. He has also held important positions with leading product lifecycle management companies, including Dassault Systems and PTC, playing an instrumental role in sales and channel management. He also has extensive experience in the manufacturing industry in driving business transformation and has also been a speaker in leading industry forums like CII, ACMA, and IMTMA on driving innovation through technology adoption. Welcome, Mr. Bajaj.
Thank you. Nice to be here.
Yeah, it's our pleasure. Also joining us today is Mr. Deepak Agrawal, a well known market research consultant with over 15 years of experience in global mobility and composites industry. Holding an MBA in marketing and finance, Mr. Agrawal has led more than 200 strategic consulting projects and worked on 200 plus syndicated reports across various industries. He has worked extensively in advanced materials, manufacturing, especially composites and chemicals, across sectors like automotive, aerospace and defense, oil and gas, construction, and recreational goods. Throughout his career, he has driven projects for both small firms and Fortune 500 companies, collaborating with many leading players in aerospace, automobile, and composite. Today, Mr. Agrawal will provide critical insights into the global additive manufacturing market, sharing data driven forecasts on this competitive industry. Welcome, Mr. Agrawal.
Thank you, Vyapak.
Mr. Bajaj, I'll start with coming to you first. So, Mr. Bajaj, many benefits of 3D printing are now well understood and well marketed in the industry. But I'm curious about the benefits that are less talked about. So, according to you, what's that underrated benefit of additive manufacturing that doesn't get enough attention, but it surely makes a big impact to begin with?
A very good question, Vyapak, and hello to everyone on the call.
Yeah.
See, when someone buys a 3D printer, he has this powerful tool of innovation that comes into their hand. More often than not, our discussions with our customers in their discovery phase are about return on investment on the prototyping stage or on some batch production or if they are making any toolings, etc. But there are incidents when immediately within 3 to 6 months of adoption of 3D printing, people have really moved into areas where they had never envisaged that they will be using this technology for.
Okay.
An example that comes to my mind is Honda India near Gurgaon. So they implemented our 3D printing on the shop floor, and they were using it for making jigs,
Okay.
fixtures, measurement tools, and so on during a part of the manufacturing process. One of those days, their industrial robots, its arm cover broke. And when they contacted the OEM in Japan, the OEM said that it will cost them 3 lakh Indian rupees and 3 months of cycle time to get that part.
Okay.
And with this 3D printer on the floor, one of the supervisors said, why don't we just engineer it here and produce this arm? And they were able to get this done in less than 10 hours and at a cost of about 3,000 Indian rupees.
Okay.
So these kind of extrapolations on the shop floor, in the design houses, on the batch production stage, there are so many ideas that come up once you have a powerful tool of innovation in your hand, and these are the stories which become very popular later on post adoption, but they are never considered as a key ingredient during the buying process.
Okay, understood. That's very interesting. To know this example of this real life example of shop floor transformation, and this really saved their cost. Of course, that's what we can make out of this example, and also the time, which is extremely important, the turnaround time. Now, let's look at the broader landscape of adoption, Mr. Bajaj. So, where do you think additive manufacturing adoption stands today? First globally and then here in India.
So this technology has been in play for almost 30 years, and globally the adoption has gone into multiple areas. It started with rapid prototyping, as we know, and moved into production support, which is essentially making jigs, tools, fixtures for shop floor workflows and processes. And then moved into the areas of batch production, and in some areas it is now moving into mass production also. Globally, all these use cases are very well established, and in India, if you look at the adoption of technology in general, not just 3D printing, if you look at various softwares or any other leading technologies about Industry 4.0, there has been a lag. Our adoption levels, both in terms of penetration and the timeline, are pretty much behind the global scales. There
Okay.
could be a few areas, like let's say the healthcare in India, which is possibly at par with the best in the world, but mostly in other areas, in the automotive space, in the aerospace areas, in terms of batch production of components, we've got a lot to catch up on. So, but the good news is that in certain areas, like UAVs and healthcare, as I mentioned a bit earlier, these areas have seen faster adoption and almost at a par with the global best in the world. So I think um, as we progress with customers, few of the key areas that we kind of take it as a responsibility as the industry leader is to make them aware of what's happening in the world, and how some of these best practices can be implemented in India, and maybe at a faster rate and at a lesser time than the global companies took.
Okay. Mr. Bajaj, help me understand why is the shift from prototyping to production so challenging? And how exactly does Stratasys help?
Good. So, see, prototyping, if you look at it, it's a little bit of an isolated part of the enterprise. You have a
Correct.
design house where there are ideas being tested. Some of them are accepted, some of them are thrown out of the window, and all people are looking at is how they can quickly play around with more and more options
Correct.
and select the best, right? But when we talk about manufacturing, it's a little bit of a serious play, right? It is not in isolation. You are a part of the shop floor. You need to be integrated with the ERP systems. There has to be a real time data capture. The problem that we face today in 3D printing is most of the people find it hard to differentiate between an entry level 3D printing and a 3D printing which comes with an overall functionality which helps them access the true power of additive, which essentially means not only you can track the processes, you have the right set of consumables, you have the right repeatability, reliability, and the accuracies that you will churn out of the system, right? In manufacturing, repeatability, reliability, and accuracy is of core importance. Very few printers in the world can do that over and over again. And
Okay.
on top of that, you need to be connected with the enterprise. That means you have to have the right softwares, which will give you either the software development kits or ready-made programs that will enable you to access this data while the parts are being printed. So that ecosystem requires a little bit of fine tuning. That also requires an adjustment into your workflows and fitting into the right ERP programs and templates. And that's when you can take it to the next level. So the problem is not as much as with the technology which is available today, it is more towards people's perception of trying to use an entry level technology which is meant for tinkering and trying to move it to production, which doesn't happen.
Okay. Understood. Okay, thank you, Mr. Bajaj, for such a wonderful clarification. And also, one of my questions was that how is Stratasys helping this out?
Sure. So Stratasys, as most of you would know, is the pioneer in 3D printing. And today we have five technologies suited for different applications of 3D printing, right from prototyping to jigs and fixtures to batch production, and in many cases to real production. Now, technology is great, but how does it talk to the other systems that are available? How secure is it? Let's say you have to interface this technology in Navy or with armed forces. Is your data set secure? Do you have the right programs that will enable you to do that? So Stratasys, since a long time, has been working on the software applications, and besides great technology, we have our own software that becomes a part of the enterprise with the right security system built in. In fact, US armed forces are using this system. There
Okay.
is a case where French Navy was able to use blockchain alongside of our 3D printing software to transfer data on the ship and 3D print a part which was required on board.
Okay.
So when it comes to giving you a complete solution around 3D printing, it is about technology, it's about software, it is about people, and it is also about how quickly you can make it actionable and implementable on the shop floor or in the design house. And that's why we have a team of people on the ground across the country, across the globe. We are about a 2,000 people company with about 8,000 plus channel partners across the globe, and about 100 of them in India, who are making this possible closer to the point of sale and where customers, offices, and production sites are. So we give a comprehensive solution which comes with hardware, software, and service, which enables a quicker success and a complete secure environment.
Okay. Okay. Wonderful. That's really wonderful. Now, thank you, Mr. Bajaj, for the wonderful clarification and also explaining the role of statuses very beautifully. Now, let's turn to Mr. Deepak Agrawal to bring the market context in this conversation. So, Mr. Agrawal, what does your research say about the current state of the global 3D printing market? I mean, what is the estimated market size right now, and what kind of growth are we expecting to see over the next 5 to 7 years, if you may?
Yeah. So, Vyapak, can you please share the screen that I
Yeah.
shared with you? Yeah. Okay. So, just first of all, just would like to add a couple of more points, about additive manufacturing, which already, Rajiv very well substantiated that points. So if you talk about any process, which gaining traction or become successful in any industry, there should be, some viability in terms of acceptance, in terms of technology readiness, in terms of supply chain and blockchain and all other details. And why AM is growing so fast, because it has been addressing a lot of key issues. So, like if you talk about, just for an example, if you talk about aerospace, G has been at very advanced stage when you talk about AM. The company actually built a product called fuel nozzle tip, which is going for CFM LEAP engine, the most sold engine product worldwide. Company has been delivering between 1,500 to 2,000 engines per year, supplying to Boeing 737 Max, Comac C919, and Airbus 320 Neo family. So earlier, the kind of material or kind of process that they have been using, they were actually developing 20 different pieces. They are welding it, making it in one pieces. But the moment they start using AM, they just built one piece. So ultimately, that helped the company to reduce the number of pieces in a component or in a part from 20 to 1. Also, if you talk about the weight of that nozzle tip, it got reduced by 25%. And in an application like aerospace or space, if you reduce even 1 pound or 1 kg, it has a substantial value in terms of overall operational cost. That's what the biggest advantage AM has been giving. Along with that, if you talk about, even I think Rajiv also mentioned about aftermarket. So with again, I give the same industry example in aerospace. There has been a lot of opportunities in MRO side, where all airlines they need parts in one or two pieces, or even up to five pieces. It's very difficult for engine and airframer to handle those pieces, to manufacture and keep them in stock. Where actually AM gives lot of advantages, and we have been witnessing a lot of potential and growth of AM in aftermarket, and particularly making certain parts, a less number of parts, giving high precision, helping the industry to address key burning challenges like weight reduction or number of parts reduced. So as per our Stratview, yeah. So we do map a lot of applications within different industries where AM has been used. So some of those industries are energy, healthcare, medical, consumer goods, automotive, food and construction. And if we talk about the AM application, it has been many. So in aerospace, the most burning one is fuel nozzle tip, which is developed by GE. The company is already planning to further invest in its two facilities, trying to install some more lines and start producing in more quantities. If you talk about energy, again there has been a lot of applications, but the most notable one are the rotor, stators, turbine nozzles. Again, the critical engine applications, and then healthcare. Again, a lot of orthopedic applications which need to be designed as per the patient body or specifications. So it's always there has been opportunity to design custom shapes better suiting the demands. Now, similarly, if you talk about automotive, again, some of the applications already mentioned, jigs and fixtures, along with some of the real automotive parts, and then there has been other applications like consumer goods, food, and construction. So again, they have a long list of applications where AM has been gaining acceptance and becoming reality in terms of market penetration. So what if you look at the past 10 or 15 years of history of AM, majority of AM was for rapid prototyping. But now what we have seen, we started seeing a transition from prototype to industrial manufacturing. And ultimately, it has a really huge impact in terms of entire AM supply chain and ecosystem. So we estimated the market of AM close to 17.4 billion US dollars. 2025 we estimate close to sorry, it will lend close to 20 billion US dollars. And within just next 7 years, ultimately is going to be around 60 billion US dollar, to be precise 59 billion US dollars. So ultimately giving a huge growth of around 16% annual, and making AM is one of the fastest growing markets or even fastest growing technologies in most of the end use markets. If we talk about aerospace organic growth, it is still around 4 to 5%. If we talk about healthcare organic growth, is still close to 5 to 6%. Construction is still oscillates between 2 to 5%. So that gives a real sense that how strong AM is going to position itself in next 5 or 7 years down the line. So in most of the industries, it is likely to have 3x or 4x than the organic growth of the industry. So moving down, like we also do a lot of breakdowns. Just a minute. We also do a lot of breakdowns in terms of different uh, categories. So, like if you talk about AM, it has been broken into materials that may be polymers, that may be ceramic, that may be metals. Similarly, broken down into the hardware, software, services. So if you look at the 2024, the breakdown was like that. 42% was hardware, where
Okay.
majority of printer lies, and then followed by material, which is around 25%, and then services around 20%, and the remaining is software around 12%. And this the share is likely to change swiftly if you talk about 2032, when there would be a lot of industrial side of production, and that gives a really transition towards more demand of materials. So from 25% we are anticipating by 2024, but within next 7 years, the material positioning would be strengthened, and it will close to be around 29%, since there would be some deliveries of industrial production and the industry will gradually to move towards industrial production. Ultimately, the printers would have some slightly share, so it's going to be around 38%. And then if we talk about services and software, if we add this together, that's going to be around 32 or 33% share by 2032. So amazingly, if you look at there has been a growth that we are trying to showcase it, to you, that for next 8 years or 7 years down the line, what would be the growth. So the average growth, as I try to explain, that is around 17% or 16.5% between 2024 to 2032. But if you talk about all four categories, they are likely to have a very strong growth. Yes, definitely, some of the categories are growing faster because of the shift towards industrial production. Material is likely to have around 18.6% CAGR. Services again are likely to have close to what material is likely to witness. But if you talk about hardware and software, again they are likely to have growth in double digits, and that clearly shows any company who is in either of the ecosystem, they are likely to have a strong financials in next 5 or 7 years. Interestingly, if you talk about regions, North America and China are the major markets. So if you talk about North America, they have around sorry 35% share. Asia Pacific is close to 30% share. So we try to give another view on further breakdown of different categories. So in hardware, which is 7.35 billion US dollar market in 2024. If you talk about how many of them were actually metal printers, 36% were metal 3D printers. Polymer was around 49%, and the remaining is hybrid and others. Interestingly, if you talk about 2024, whatever hardware business is, industrial printers having around 65 to 70% share. Out of that, if you talk about the FDM, which is fused deposition method, they have around 20 or 25% share. So that shows, where exactly industry is moving, where there has been a proper shift towards industrial side of AM manufacturing. Similarly, if you talk about AM softwares, we do see a lot of growth in simulation side, having 25% share. And if you talk about build preparations and MES workflow, so they have also have a sizable share.
Okay.
Powder, which is very much discussed, many of our customers wanted to understand what exactly happening in different industries in terms of metals, polymers, and ceramic. So metals is very much dominant, 55% share. There are plenty of companies who are actually manufacturing metal powders and has been supplying to different end use or different end use markets. But we see a lot of growth in polymer side also. So we see a lot of polymer growth in both powder as well as filament applications, where sorry, the material is likely to grow at a very fast rate. Just to add one couple of more points here, like if you talk about the patents, which shows how strong the industry is in terms of innovations. So if you talk about since 2001, there has been more than 50,000 international patents families. Some sources says it's close to 180,000 patents filed. Out of that, 38,000 just being in 2025, mid 2025. That shows the industry eagerness to keep developing advanced products. And US and China leads with around 50,000, close to that. In terms of companies, GE, Raytheon, mainly, if you talk about aerospace companies, named any big tier player, GE, Raytheon, Safran, or maybe like Rolls Royce, all are into the race of doing developing innovative solutions in AM technologies. That shows how strong the base is in terms of market adoption. Sorry, the penetration could be very low as of now, because some industries still they rely on certain processes. But gradually we foresee that the penetration rate of AM is likely to increase tremendously, especially those areas which are very critical in terms of geometry, where the weight reduction has been substantial, and being counted as one of the biggest factors. Also, the process in terms of available technologies is still very complex. So these three areas, we do see, the advantage of AM, and they are likely to make a big impact in coming time, in global as well as in Indian market.
All right. Yeah. All right. Thank you so much, Mr. Agrawal, for those really interesting insights. And what we have been discussing here, we just got to have a look at it in terms of numbers. So that was really illuminating, I guess. Uh, you know, Now, Mr. Bajaj, let's now return to you, right? For additive manufacturing to truly scale and capture a larger piece of that forecasted market, I'm sure that cost is going to be a critical factor for sure, right? So, Mr. Bajaj, how do you see the economics of additive manufacturing evolving over, say, next 5 to 10 years?
Yeah, good question. So, good insights, Deepak. So, over the next 5 to 10 years, there will be multiple fronts for development of additive manufacturing as a technology, or the machines, as we call them. They have to definitely become fast, more price competitive. Today, if you look at 3D printing process versus a conventional molding process or any casting process, the speeds are very different. So that's one area where most organizations are more important one, as I would call it, is the choices of materials. The application scope is going to expand in the coming 5, 10 plus years. The adoption of 3D printing will rise to multiple other areas, which will demand more specialized materials, possibly cheaper materials which has high deflection temperature, which is more stronger than some of the other alternatives, and so on. So there will be a lot of development towards the material side. And finally, there are options which will give users the ability to fine tune their own material in case the available materials do not satisfy the requirement, wherein machines will have open software, and to an extent hardware capabilities, where people can fine tune their own materials for some specific application use that they are looking for.
Correct.
And third one would be around the software part, which will make it an integral part of the overall manufacturing workflow. The software will have to possibly consider all the aspects of design integration, manufacturing process integration, talking to the MRO systems, MRP systems, and ERP systems. And later on, as we develop, AI will start playing a role in it, possibly, which we can talk about a bit later.
Okay, understood. Mr. Bajaj, can you tell me which industries are adopting additive manufacturing the fastest right now? I mean, there would be some industries for sure, right?
So traditionally, if you trace the history of 3D printing technology, or even the softwares that are sold in similar industries, aerospace and automotive have been the earliest adopters of such technologies, and that's where the whole manufacturing life cycle starts generally for high-end application. So in that similar lines, the automotive and aerospace domains have been a very big user of this technology. As the demand for, let's say, customized vehicles or model refresh in less than 18 months, or a new car design within less than 3 years, or move to EV, as it becomes more and more integral part of our life, we will see a faster implementation and integration of technologies like 3D printing into the mainstream design through manufacturing life cycle of these automotive areas. The second one, if we talk about unmanned aerial vehicles, drones, these are very typical use cases of additive manufacturing, which are low volume, high complexity. These are the best applications for 3D printing, where you have low batch sizes but varying complexity, which you can easily cater to with a certain set of machines. And there are live examples even in our country where People are developing production quality drones in high numbers without even investing in any traditional molding manufacturing facilities. And of course, there are new trends emerging like personalization or hyper personalization, which essentially means that you are going to tweak your product to suit an individual user need. 3D printing as a technology, additive manufacturing as an ecosystem, uh, levies no penalty for complexity of design or requirement. So if I'm going to, let's say, print three different phone covers today, one with your name, one with Deepak's name, and the third one with mine, I don't need three different molds for that. I can print it on the same bed size of the machine. Within 1 hour, we will have three different colors, three different names on that mobile cover without any complexity. So as personalization and hyper personalization become more important, and these could be in consumer goods areas. These could also be in automotive area. For example, we did a project with the BMW Mini in China, where we customized a side scuttle, the side lamp with the indicator lamp of the vehicle, suiting to an individual's requirement. So they could give any design, they could give a family picture or something that they love, and we could make it as a part of the final vehicle.
Okay, wonderful.
The best part is that 2 years later, you get bored with it, you can actually change it to a new part. So these trends will play a major role in the adoption of 3D printing overall.
Okay, so my next intended question was about such examples in the automotive industry only, but since you've already answered it, so I'll just move forward. So, Rajiv, Mr. Bajaj, I would just want to know how exactly are Indian automotive players responding to it? You have any specific examples with Stratasys?
See, the adoption in India, as I had spoken earlier, is definitely gaining traction. Today, all our OEMs and tier one suppliers are using 3D printing technology.
Okay,
Almost all of them are Stratasys customers too.
okay.
And we have great stories right from prototyping to manufacturing. But the nature of 3D printing applications is such that they are pretty confidential projects, the cutting edge projects that people are coming with, out with. But if I take the names of leading manufacturers like Maruti Suzuki, Honda India, Volkswagen, Mahindra, Ashok Leyland, they have all been using our technology for a great use. Maybe I can give you an example from Ashok Leyland. Back in the days, about 3 years ago, or a little more, the commercial motor vehicle regulation authority came with a regulation that all the trucks need to have either an air con or a
Okay,
cooler in the trucks. Why? To avoid driver fatigue, which was a major cause of the road accidents in the country.
okay, correct.
But they gave only 3 months of time to the manufacturers to implement it.
Okay.
And given the current cycle times, a company like Leyland, they shared with us, they were taking just 3 months to make soft molds for such a housing design, check it, test it, and then finally go for mass production. But using Stratasys 3D printing technology, in particular Fortus 450 FDM machine that they use since 2016, they were able to capture the entire design in 3 days. They manufactured it using our 3D printer. They put it on the truck. They ran it in their test circuit, and it the design was thankfully first time right, and they moved it to production very quickly. So there
Okay.
are multiple such examples with our Indian manufacturers who have utilized this technology either for this kind of heavy duty prototyping, or for bridge to production, or for applications like the robo arm that was not even a part of the overall implementation when we had started the process.
Wonderful, truly a wonderful example. Since we're talking about automotive right now, we've actually got a comment from Aniket Roy. So we'll just take it up right here. So Aniket is has dropped this comment on LinkedIn. He says, in automotive, we are looking rapid electrification across all segments. Now we know that the internal mechanism of EVs is very different from the ICE vehicles, right?
Right.
So where does AM stand in this electrification landscape in automotive?
See, anywhere where there is a new development, AM will play a key role in the overall product development cycle. If you want to test the motors, you want to test any other prototype, housing, how does it look? There was a case where Minda, using our machine in Pune, they said when they were looking at coming out with electric solutions, they wanted to see the housing for the battery, how it will be fitted, will the driver himself be able to take it out, what efforts will be required in changing. So all these iterations they could check with 3D printing very quickly and make it a part of the overall production product development life cycle. So wherever there is a new trend, new change, or a limited production required, these technology will play an integral role.
Correct, correct. I think I hope Aniket has got his answer. Uh, Now, also, I would also we actually have discussed briefly about this, but I would actually want to know more about the defense and aerospace. Like, how exactly are aerospace and defense organizations leveraging additive manufacturing today, and what are the unique challenges or opportunities that you see in this sector?
So maybe I'll answer this question in two ways. One about the global application and something about India that we can talk about.
Yeah, totally wonderful.
See,
Yeah, that'd be
yeah.
great.
So global aerospace and defense. Of course, we are a integral part of the new product development. So anything to do with prototyping, definitely we are there. Now, where industrial applications and companies like Stratasys help, we have a wide variety of materials and that are suitable for aerospace use. In particular, there is a, certification called FST, which is Flame, Smoke, and Toxicity
Okay.
certification that is required for certain materials. So we have a material called Ultem, which can actually be manufactured using Stratasys 3D printers, and it can be made a part of the interior of the aircraft. Airbus has actually used our technology in one of their not one of many of their aircrafts to cut down as weight, as Deepak has mentioned earlier, and also the cycle times.
Correct.
But if you look at it, any process or any technology that needs to be brought inside the aerospace industry has to have a very high level of conformance. You just can't put a machine or a part or an application and say that, okay, tomorrow I will make aerospace part out of this technology. You cannot. Why? Because everything has to have a traceability. Anything that you design, anything that you manufacture, anything that goes on an aircraft or space product has to have a complete traceability to the place where the material was manufactured, from the warehouse your material was shipped, and the entire process that the machine uses to manufacture or 3D print that material. And you could count on fingers, maybe one or two organizations are ready for providing that level of um, um, compatibility for the aerospace industry. So therefore, we are seeing a very high level of adoption globally. Now, if you come to India and we look at our aerospace industry here, both civil and as well as defense, one of our biggest problem is part obsolescence. There are older aircrafts, there are older weapon systems, there are older vehicles. Many
Correct.
parts are missing. It could be very small parts like a handle, like a knob, or a gear shifter. Now, in some of the cases, or in many of the cases, the drawings are not there. In some of the cases, the suppliers are not there. And if you ask them for let's say a small handle or something, they will say, okay, minimum order quantity is 1000, and all you need is one or two of those handles. And that's where 3D printing, and specifically 3D printers which is aerospace certified, to play. And we are helping these organizations with fighting with part obsolescence, and we are able to give them the same part at a much lower cost and in a much shorter time, and in the form of a digital inventory. Today we give you one, tomorrow you need one more, just press the button, 8 hours, 10 hours, whatever be the part size, the part is printed and given to you after the right processing. So these are some of the areas where we are working in the aerospace industry.
Correct, correct. Wonderful. So, since we're talking about all of these industries, so we've spoken in length about the automobile industry, aerospace and defense industries. These are much talked about industries and have been in this conversation. But I would also want to know about how mature is the additive manufacturing adoption in healthcare today, specifically in India also. No. Yeah.
That's an interesting question, and that's a question close to my heart. And this is something because which is changing the quality of life, and we are able to provide better quality of outcomes after surgeries to patients. And I am very proud and happy to say that the level of adoption of healthcare 3D printing in India is at par with the global scale.
Wonderful.
Maybe not in terms of number of units of the printers, but the way it is being used, the way surgeons are saving lives, and the way device companies are using the 3D printing in developing new medical devices. So there are three uses of 3D printing in healthcare. First of all is the point of care, which is when you go to the hospital, and when someone goes to the hospital, they need a complex surgery. Complex surgeries are, let's say, a congenital heart defect. A congenital heart defect is a kid who's born with a defect in the heart, which is God's design gone wrong, and many of the trained doctors also cannot visualize it in 2D, and the
Okay.
heart size is so small, a few millimeters, and that's where 3D printing plays a role. You can actually print it to size based on the scans that are available, the CT scans, and the surgeons can plan the surgery. In fact, we've had conversations with the likes of Dr. Shetty, Dr. Devi Shetty of Narayan Hrudayalaya, who said that it is sometimes the patients, the infants, don't get the right care because the surgeons in villages or some cities in the country are not sure to open up before the surgery because they're not sure what the problem is, and you don't have enough time to conduct the surgery. But with 3D printing, if you have the model in your hand, you can visualize it, you can see it in 3D, you can practice the mock surgery as nicely as you would do it on a real patient, and then give a better patient outcome in such cases. Extremely critical. The same applies to neurosurgery, where there is a complex tumor in the brain, or a kidney tumor where you have to do a partial nephrectomy and remove a part of the kidney, but uh, keep the remaining part of the kidney safe so that the patient can have a longer life. Great use cases, and I'm very proud that in India we are having application of this 3D printing across the country. Hospitals like AIMS Delhi, AIMS Bhopal, MGM in Aurangabad, and many more are using this very successful.
Okay, wonderful. Wonderful to
The
know this.
second one, yeah, just I'll add on to the second
Yeah,
use
sure.
case.
Please go
Do we
on.
have time? Yeah, we do, right?
Yeah.
So the second use case is about medical devices. Now, medical device manufacturers need support on two fronts. One is the regular prototyping that you would need for any product development, but the second is availability of human anatomy to test this, and not enough anatomies are available.
Correct.
So that's where they use our 3D printer for getting access. And the third one is medical education and research. We all know getting access to cadavers is very difficult, and the students do not have enough bodies to practice their surgeries on. Even if they get access to the body may not be with the exact anomaly on which they want to test the surgery on. Now, that's where Stratasys 3D printing solutions comes into play. We have a solution called digital anatomy printer,
Okay.
which actually produces a tissue-like look, feel, and interface with the scalpel, so that the surgery can be practiced in the same way. The bone structure, the tissue, and it is also X-ray friendly, so you can use it for making phantom models that
Okay.
these companies, medical device companies, use for their device development. So across these three factors, healthcare 3D printing is becoming very popular, and it is actually closer to our heart because it is a cause that we serve in getting better quality of healthcare to individuals.
Okay, understood. So thank you, Mr. Bajaj, and it was really interesting to listen to how the additive manufacturing is not only helping narrow down manufacturing efforts, but also impacting lives directly, and it's really heartwarming to listen to this. So thank you, Mr. Bajaj, for these extremely detailed breakdowns of these industries. So we will quickly take a question from Mr. Deepak. I ask a question to Mr. Deepak Agrawal, and we will uh, save 10 minutes of our time for the questions in the last. So, Mr. Agrawal, let's bring the market data back in. So, since we've been talking about these industries, right, automotive, healthcare, aerospace. So, what does our research say about this? Can you help us quantify how these different industries are contributing to the global 3D printing market share based on your research and forecast?
Yes, yes, sure. So, if you talk about, like, obviously, every market has different aspects. So commercial viability is one, everyone later looks after, because that actually, gives interest to companies to further invest and further explore the opportunities available in the market. So if we talk about the opportunities available within different area of industries for AM, and if you break down that industries into major ones, the aerospace, energy, healthcare, consumer goods, automotive, industrial or tooling applications, and construction remains the major one. So interestingly, if you look at that, like as of now, the biggest market is what? The biggest markets are very less. Like if you talk about industrial tooling, which is really sizable, having around 22% share. If you talk about healthcare, Rajiv already explained why AM is so critical in healthcare. So it's having again a sizable share of around 20%. Aerospace, like around 60%. And generally, whenever you talk about any high performance industry, aerospace remains one of the major ones. Why? Because the moment any material or any process got success in terms of commercialization, actually it gives a lot of opportunities to implement that technology in other industries. So always, industries look after how exactly that particular technology positioned in aerospace. So in AM, it's already being successful, marking a strong position around 15% share. And then if we talk about other industries like energy, which is having around 10% share, and so on. But importantly, again, all industries are witnessing very fast growth. Important is we believe industrial tooling and fastest growing market. The reason being that the applicability of AM in tool applications, jigs and fixtures already mentioned by Rajiv, why it is so critical to have AM in those applications. Aerospace is likely to have around 15% CAGR, majority of them driven by, two areas. One is engine applications, another is interiors, which is talking about FST applications. So where we see a lot of usage of polymers, including Ultim of Sabic, which Rajiv tried to explain in for Airbus usage. So why? Because there are two reasons. One is it gives a lot of benefits in terms of weight saving, and in aerospace and space, weight saving remains one of the most critical driving factor. Along with that, aftermarket, where we see a lot of potential of AM in aerospace. Healthcare remains one of the largest end use by 2032, remain one of the leading market in terms of demand generator. Energy, again, is likely to have a really sizable growth, mainly driven by industrial turbines, where applications like turbine blades in areas like hydrogen and nuclear parts would remain driving the major parts. Automotive, again, having really good growth, around 14% CAGR in next 7 years down the line, mainly driven by the changes or the paradigm shift towards EV. And one more thing, like, what's happening, and that's again very true for Indian market. The company keeps launching new variants, and whenever they launch new variants, they make certain changes, and whenever they make certain changes, they need new molds, they new jigs and rig fixtures, and where exactly AM can play a big role in that. So among, if you talk about all end industries, we see a lot of good growth in coming years. We believe tooling is likely to be the biggest one in terms of growth percentage, but aerospace, energy, healthcare would remain the major ones in coming 5 or 7 years down the line.
All right. Thank you. Thank you so much, Mr. Agrawal, for these wonderful insights. Now, we will take a few questions from the live chat before we wrap up this session. So, Gaurav has this question for Yeah, so let me just bring Gaurav's question on the screen. So Gaurav has this question: how does AM and 3D printing industry deal with challenges in standardized processes and quality control, cybersecurity, and a shortage of skilled labor and expertise? Yeah, we have discussed a bit about cybersecurity, but shortage of skilled labor and expertise. Your views on it, Rajiv, Mr. Bajaj.
You can call me Rajiv. I have no problems. Please call me Rajiv. And actually, we did talk about it. And to the last part, skilled labor and expertise. In fact, 3D printing as a technology is one of the easiest to use and implement. And of course, there are enough places for people to learn and understand it. Plus, we have our own applications and service organizations that handle and skill the people. um, and a lot of it, once you set up the workflows along with the software, the process, and the design methodologies, it becomes a easier challenge to handle. And 3D printer, it in itself, sometimes if you look at the manual processes, the more the complexity of the part, the more skill you need to make it. But in additive manufacturing, if you can design it on the screen, you can print it no matter what. So some of these areas automatically get attended.
Okay. We will take. I hope that answered your question, Gaurav. Thanks for asking. And we will move to the next question. So, Manas has this question: that what major technological breakthroughs are expected to significantly reduce cost per part in the next 5 years?
Like, I can't predict the future, but as I was speaking a bit earlier, that access to open materials, most hardware suppliers, including ourselves, we've already given access to people to be able to use any choice of material that they would like, and then it is driven by market forces. Once you have a wide choice of materials that you can use, till about 5 years ago, you could only use, as an example, only the materials that the 3D printing hardware providers are giving to you. But today, you can scout for material in the open market. And once you have the access to the open market, the market forces bring the cost down themselves. So this opening of the hardware will play a major role, and the software which will enable you to fine tune those open materials for the hardware that you're using will further help you to bring down the costs.
Okay. Well, I hope that answered your question, Manas. Thanks for asking. Also, we have this question. Aditya has to ask about the defense industry. I want to ask, like, we've heard examples of AIM being useful for spare parts and defense equipment to places where supplying spare parts is difficult. To what extent does AIM solve such challenges?
AM actually is a great solution because you don't have to set up a production line for manufacturing the part, right? So we have examples which I gave for a French Navy where the printer was on the ship and the part was manufactured there. In fact, in some of the recent conflicts that they've happened, without taking the names, the machines were installed closer to the point of use where people were either replenishing the parts that they were using and reproducing at the touch of a button about the parts that were needed. Basically, if you look at running a 3D printer, it is standard equipment that you can keep in one corner of a room or at any location which has access to power and a clean environment. And that's what it needs.
Thank you. Thanks for the wonderful answer. Mr. Bajaj, we actually had this question, and this would be the last question that we're taking from the chat since we're running out of time. So,
Mhm.
Anna has this question, and this was one of our questions that we had decided to ask, but skipped it because we got this question in the comments. How is the AI wave affecting the additive manufacturing space?
So a little early for AI to be adopted in 3D printing as of today, but a lot of work is going on
Okay.
in a few areas, and maybe I can talk about major areas where the work is going on. The first one is the in-process monitoring and optimization. As of today, in most cases, you press the button and you get the part only when it is printed, right? But with the application of AI, we could implement monitoring and optimization of the printing process itself. Then, though 3D printers can produce any complex geometries, but there could be areas which still have some challenges in making that part. It could be a large overhang or a very thin wall. Uh, AI possibly could give advanced toolpath control in such cases where you can build a very highly intricate geometry. Thirdly, could be the preventing the maintenance of the machine and smarter machine management. Some of it has been already being used in other parts of machines.
Okay.
And finally, about quality assurance and process stability, which takes it to smart factory integration, which connects the machines, the sensors, and the production workflows.
All right.
So finally, it will not work in isolation. Finally, the 3D printer will be a part of your overall product development workflow.
All right. Understood. Thank you for that answer, Mr. Bajaj, and also thank you, Anna, for asking. So that was truly illuminating, and we've covered tremendous ground today, from economics and adoption to deep diving into industrial applications. And as we bring this conversation to a close, because we are running out of time now, so I'd like to ask both of you for your final thoughts to leave our audience with. So, Mr. Bajaj, what are your concluding thoughts on the role of additive manufacturing for global, or say Indian manufacturing? A quick word.
So maybe I will limit my thoughts to the application of 3D printing in the Indian industry, and it's almost my message. It's not a new technology. This technology is almost 30 years old, and in many cases, people are still benchmarking and seeing what they want to do with this technology. So we are already 30 years late.
Okay.
How late do you want to be? And also, as a economy, as an nation, we need to move away from the concept of cost saving to the concept of innovation. Most of our discussions with customers about technology adoption, I mean, I was previously in software, now I'm in 3D printer hardware selling. People are more worried about what cost they are saving than the opportunity they are getting with implementing this technology. So we need to move towards innovation. We need to start thinking, how can we make products coming out of India representable at a global stage? And that's where a true technology adoption at scale will take place.
Thank you. Thank you so much for that, Rajiv. All right. Now, Mr. Agarwal, your final thoughts about how it's going to be for the additive manufacturing, as a market.
So it's already very well summarized by Rajiv. So just want to add global perspective in that. So for global perspective, if you talk about any success, AI is already get successful in terms of positioning itself in crucial parts. And what happens, if you look at the history of any technology roadmap, it takes a lot time in from the design to acceptance, and then there has been a rapid growth. So what we see as a company, that the next 5 or 10 years are going to be extremely rosy in terms of penetration, in terms of adoption, not only in one area but across industries. But definitely there should be some highlights, or some area, like certain areas where we see a lot of higher growth for AM, particularly in aerospace, defense, healthcare, where technology does matter a lot. So the next 5 or 7 years, there has been an extremely good for AM community, no matter where exactly they situated, in software, material, printer, or maybe services. All are likely to witness strong growth across regions, across countries. So this is what we believe and we see in terms of next 5 or 7 years down the line.
Okay. All right. All are likely to have strong growth is the key takeaway that I'm taking, and I guess our audience is taking from this session. And with that, we come to the end of today's session. I really think this was a very meaningful and productive conversation. I hope you two had a good time sharing your insights, Mr. Bajaj and Mr. Agrawal.
Yes. Thank
Thank
you
you,
very much.
Vyapak. Very interesting questions, and thank you to the audience for joining the call.
Thank you, everyone. Yeah.
And we would love to have more of such sessions with you in the future. And perhaps we can have something like panel discussion with multiple experts next time on these topics.
Absolutely.
Absolutely. So, all right,
Thank you.
wrapping it up to both our speakers, Mr. Bajaj and Mr. Agrawal, I sincerely express my sincere thanks for your time, your clarity, and for sharing insights that were both strategic and grounded in real world experience. It is indeed really rare to have such a rich multidimensional view of a sector as complex and promising as additive manufacturing industry. Also, to everyone who joined us today, thank you for tuning in. Whether you are an industry insider, a potential investor, or simply a curious mind, we hope this session gave you valuable takeaways. Meanwhile, keep the track of our LinkedIn page to get notified in the future as we host such webinars on variety of topics regularly. Thank you, everyone. Thank you for connecting. Thank you, Rajiv. Thank you, Mr. Bajaj, and thank you, Mr. Agrawal.
Thank,
Thanks for joining.
thank you,
Thanks
Vyapak.
everyone.
Yeah.
Bye bye. Bye.
Bye bye.